Ladies and gentlemen, class recording has started. So, like I said, hopefully you remember that tomorrow you have a test. As far as this unit is concerned, oh, not that.
Do that later.
Alright, as far as this unit is concerned, this unit started back on November 28th. It was the Wednesday after we got back from Thanksgiving. So we started off introducing the idea of projectile motion. Motion in two dimensions. Objects under the influence of gravity, but now instead of just moving up and down, now we've also added this sideways motion. And we'll talk more about concepts a little bit later on. So we started that off. Then we continued on with some practice problems on November 30th, dealing with what we call horizontal launch. We'll explain that a little bit more, make sure we review that a little bit more in a second. Then on Monday, December 3rd, you had your first quiz, horizontal launch projectile motion quiz. I gave that back to you last week. After the quiz on Monday, December 3rd, we got into changing the way that something became a projectile. We moved on to our angle launch problem. So we did some angle launch problems on Monday and Tuesday. Then on Wednesday of last week, we went down to the PAC and took some data so we can calculate the initial velocity of some throws at an angle. And then on Friday, you took your angle launch quiz. Today, we will review and then test tomorrow. As far as some other resources that you have in this chapter, or this unit, first, you got your two quizzes. You got two problem sets. One said projectile motion horizontal launch. One said projectile motion angle launch. Answers to both of those problem sets are posted online, so you can check that out. I also recorded class a couple of days, going over the beginning of the horizontal launch problems, but also the beginning of the angle launch problems. Hopefully getting some details there. So you have all those things available to you as you go to study. Okay? Questions as far as the test is concerned to begin with? As far as the actual format of the test goes, test is, I believe, 9 multiple choice questions, and then there are 4 problems. Points-wise, I think it's 36 or 7, if I remember correctly. So it's about the same as the last test. So last test was about that much. But this test, much more portion of the problem skewed, or much more portion of the points skewed towards the problems than the multiple choice questions. So a lot of people like this, and a lot of people like that test. And we'll see that the next couple of tests are like that because we're reviewing the stuff that we've done in one dimension, now applying it to 2 dimensions. So it's much more problem heavy than it is concept heavy. Alright, good there? Note card. Obviously, you can make note card if you would like. Example problems, concepts, notes, whatever you want. And as long as it's not a random sequence of letters, but I added a couple new questions this year, so that'll probably not work for you. So just throw it out there. Alright, good there? Let's start first with talking about our first kind of problem. So our first kind of problem started off on top of a ledge, and here's the ground down here. And the first kind of problem we talked about was the horizontal launch. There we go. So we said we stand on top of this cliff and either throw or launch or kick or whatever something in the horizontal direction. But as soon as it leaves the ledge, what starts acting on it? Gravity. Will it ever follow this blue arrow that I've drawn here? No, right? Gravity starts pulling it off of that path and starts pulling it down. But, as we discussed, it doesn't lose that horizontal portion of its motion, so now it's doing 2 things at the same time. It's moving both horizontally and vertically. The end result of that is what shape? Parabola, or in this case, half a parabola, right? That takes us right around there. Okay? As far as looking at the flight of this parabola, horizontally, if we neglect air resistance, we said that the horizontal velocity remains the same the entire flight. Ooh, not what I wanted to do. The horizontal velocity will remain the same the entire flight, so we can just clone that there, and then we can do one more here. It might run off the edge, but that's okay. But as it's moving horizontally now, we said gravity is acting on it. So what is gravity doing to it vertically? Pulling it downward, but also as it's pulling it downwards, it's speeding it up. Just like if we dropped an object from the top of this ledge, the same thing would happen. So at the beginning, right, at this point, there is no vertical velocity, because it's moving all horizontally. But as this object travels along, right, it starts having a vertical velocity, and that vertical velocity will keep increasing. But it will actually be vertical. There we go. Okay. Good there? And we said if we wanted to look at the actual speed of this object at that point, we have to take into account both of those velocities that are happening at the same time. So the actual speed of the object at this point would look something like this, because that's our combination of both the horizontal motion that doesn't change plus the increasing vertical velocity. How did we say we were going to find that purple line if we needed to, or the purple arrow if we needed to? Okay. We said that we can do that by taking the red portion, right, moving it over this way. Goodness gracious. There we go. I cannot tell from standing up here. Is that better?
Yeah.
Okay. All right. So that we can take that horizontal velocity, or sorry, the vertical velocity, and make a triangle with the horizontal velocity. We call this one the resultant vector, right? And the resultant vector is the sum of these two velocities. But you can't just add them together, right? That's where we use Pythagorean theorem to figure out what the velocity is at that point in time. Good job, or good there? Questions on that? Okay. As far as some concept questions go, I was going to do some text polling today, but the text polling takes a little while, so I had already made up the questions, and I was just like, okay, we're just going to talk about them in class. So, first question. Here's this cannon, right? You've seen this cannon, from your lab the other day, right? It's up on top of this ledge, 15 meters off the ground. So it says, if I shot a bunch of different objects out of this cannon, which one would take the least amount of time to hit the ground? Golf ball, tank shell, adult human, or Buick? Or the last option, they'll all hit the ground at the same time. And the correct answer is?
Well, technically the tank shell because it has the least air.
Neglecting it.
But we've neglected air resistance, right? Okay. So in the absence of air resistance, which one's going to hit the ground at the same time? Or all of them will hit the ground at the same time. Because what determines how long it's going to take them to hit the ground? Gravity. Does it matter that they're moving horizontally? No. And in this case, it doesn't matter what they are, because what do we know that gravity does to all objects? Gravity affects all objects exactly the same, regardless of their size or mass, or regardless if they're falling straight down, or regardless if they're moving horizontally. Okay? Next question. This time I'm going to shoot a pumpkin out of that cannon, except the first time I'm going to shoot the pumpkin out at 10 meters per second, second 15 meters per second, third 20 meters per second. Which one's going to hit the ground first, or which one's going to take the least amount of time to get to the ground? Answer is all are going to hit the ground at the same time. Because what causes them to hit the ground? What causes them to move downward? Gravity. Does it matter how fast I shoot them horizontally? Does not. Regardless of how fast I shoot them horizontally, they will all hit the ground at the same time. Unless, what?
They haven't already.
No, not yet. Okay? Unless I do this. Right? Okay?
Did you like
Magic.
take multiple pictures and cut it out?
No, come on.
You can just do 3 cans.
soft paint you can.
Why is that?
Oh, I thought you were talking about like me actually cutting them out and taping them. So no, I did not. But yeah, it's just paint. So I took screenshots and. But anyway, in this case,
Now the 15.3 meters is.
yeah, just only applies to the top one. So. But in this case, okay, pumpkin from 5 meters, pumpkin from 10 meters, pumpkin from 15. Which one's going to hit the ground first in this case? Pumpkin from 5 will hit the ground first. Does it matter how fast I shoot them? No. I could shoot the pumpkin from 5 meters the fastest horizontally out of all 3 of them. That would not mean that it's not going to hit the ground first. It will always hit the ground first. Which component determines the flight time of this projectile? Well, the height, or which height specifically? The vertical height, because the gravity pulls it downward. It does not matter what's going on horizontally. The vertical components will determine the flight time here. That good? Questions there? Okay. Next thing that we did was launched a projectile, but now, instead of launching it from a high perch and shooting it horizontally, we shot it like this. And we said we called this here angle launch. Angle launch. Okay? So the one thing that changed here now was what? What was the big difference between this problem and the previous problem? What do we have to do? Okay, this purple line, the initial velocity of this projectile, is really a combination of 2 things. This projectile is moving horizontally, but it's also moving vertically at the same time. The combined effect of that is this purple velocity here. But if we know the angle, or if we know the speed at which it was shot, and then we know this angle theta here, we can use our trig identities to find these 2 sides of the triangle. What did we do with those 2 sides of the triangle once we found them? This becomes our initial vertical velocity, and this becomes our initial horizontal velocity. Okay, go ahead.
They gave you the angle like on the other side. Could you still do the same thing?
Yeah, it's just a matter of which triangle you. It's just you. Yeah, like because we could also make. Okay, you could also make this triangle,
Okay.
and it would be exactly the same numbers. Just make sure you got your theta straight. Although usually they give you theta in relation to the ground in a situation like this, but you could make that triangle and it'd be perfectly fine. Still give you the same exact numbers, just the angle would be different. So. Okay. All right. So we got this here, right? Those become our initial horizontal and vertical velocities. But we discussed, does this object ever take the path that it's initially shot at? As soon as it gets launched, what starts acting on it? Gravity, right? And now gravity will take it off of this original path and take it in this parabolic path. The first type of problem that we did, we talked about this object landing at the same level that it was launched from. And that in that case, there's a couple of specific spots that we can make some assumptions about the motion of that object. The first spot we talked about was this spot right here. Okay. What do we know about that spot right there? The velocity vertical is equal to 0. What's true about that point right there? If the vertical velocity is 0, what does that do for us? That means what stopped happening? It stopped moving upward, right? Meaning what's true about this right here? This is the maximum vertical displacement from the launching spot. Does that make sense? Okay. If it stops moving upward, where's it going to start going? Downwards. That's the highest it's going to get. Okay. The other spot that we talked about was this spot right here, right before it hits the ground, or right before it lands back at the level that it was launched from. So, a couple more assumptions we can make about that spot. What's one assumption that we said we could make about that spot? That its vertical velocity at this point is equal to the negative initial velocity. Same component, right? Except now it's moving downward. Okay? Value would be the same, but now it's moving downward. And then what other assumption that we make at that point in time? Where does it end up height-wise? If it's the same level, where does it end up in relation to where it started? Same spot, so that means that delta y would now be equal to 0. Good there? Alright, to go through some of these ideas, here is a question from your book. This is a picture at the end of chapter 7. Okay? It shows you the flight path of this object that's launched out of a cannon, not the same cannon from before, but different cannon. And it has 4 questions that it wants you to answer. I'd like you to take 2 minutes, discuss in your small groups the answer to these 4 questions, and we'll come back as a big group and talk about them together. 2 minutes, go! Alright. So, this is a question from page 170 of your textbook, asking you to compare some of the different properties of this flight at different points in its path. First, where is the magnitude of the vertical velocity the greatest? So, vertical velocity being affected by gravity, right? I already established, I told you that E is below A, so that means that the vertical velocity will be greatest at point E. It starts off the vertical velocity, right? At the beginning, there's an upwards component, and then there's a sideways component, right? That upwards component gets smaller as the object moves up and bigger as it moves down. But because E is below where it started, it'll be bigger in the downward direction than it ever started in the upward direction. Good there? B, where is the magnitude of the horizontal velocity component the greatest? Correct answer there? Horizontal velocity is exactly the same at every single point of that flight, because the horizontal acceleration is 0, as long as we do what, Evan? Neglect air resistance, which you will do so on the test tomorrow. So the horizontal velocity is exactly the same the entire time. C, where is the vertical velocity the smallest?
Is this magnitude or?
It doesn't matter to answer this question. Because, well, why are you asking?
Because if it's not magnitude,
Uh-huh.
then you would have a negative in one side.
But does that mean it's smaller, though?
If it's negative, it would be less than, so that means, so it is asking for
The
magnitude.
negative does not tell you anything about how big or how small it is, right?
Right, but, I mean, you would have negative on one side of the curve.
But that doesn't mean it's bigger or smaller, that just means it's moving up or down, right? Negative
So
2
it is
is,
asking if.
It's physics, not math. It's different.
negative 2 is bigger than positive 1.
Yeah, so it is asking for magnitude.
It's asking you for where's the velocity the greatest?
Yeah.
Or smallest. That's what it's asking you.
Whatever.
The answer for C is C. Because why? It's the highest point. It may not be the actual highest point of the flight, but if it's closest to the top, that means it's going to be the smallest. regardless of whether it's going up or down. Then for D, where is the acceleration the smallest? The answer there is the acceleration is exactly the same throughout the entire flight. Because what's the only thing that's affecting it? Gravity. And gravity doesn't change from A to B to C to D, or E. Okay. Yes, Jeff?
I have a question for A.
Yep.
What if it was one of those perfect parabola things?
You mean something like this?
Yeah.
Okay. John, anywhere that we draw this horizontal line, what can you tell me about the speed on the two parts of the curve? Anytime, any one of these horizontal lines, like this one here or this one here, what can you tell me about its speed at this point versus this point?
They're the same except opposite.
So their speed is the same, right?
Yeah.
Is their velocity the same?
No.
No. Does that make sense? Okay? So yeah, anytime we draw a horizontal line, that's going to be the same. And that's true, John, even with this bottom one, right? When the object gets back to this point right here, it's going just as fast as when it was launched. But in this case, too, it doesn't stop there, though. It continues going on. So it actually hits the ground with a greater velocity than it was launched with, because it's not the same height. But if it was, it would be. Is that good there? Good conceptually on those questions? All right. Let's talk about, we'll talk about this one here, okay? At this point, if we do a 45-degree launch, so this angle right here being 45 degrees, what's so special about that point? What's so special about the log angle of 45?
Both sides are the same.
Both sides are the same, right? A 45, 45, 90 triangle is going to have just as much horizontal component as it does vertical components. Straight? Okay. So this is my original launch velocity. But like we said, it doesn't follow that path. But as far as looking at the flight of this object, 45 degrees will give us maximum range. Okay. What did we say range was a fancy word for? We talked about it like one day, but it's not real special. Right? Anybody remember? Range is delta x, right? The horizontal displacement. So at 45 degrees, you will get the largest horizontal displacement if no air resistance. Okay. Good there? That means in something like this situation, 30-degree launch, 60-degree launch. Okay. What's true about how far away 30 is from 45 than 60? That was a crappy question. 30 degrees is how many below 45? 15. 60 degrees is how many above 45? 15. So it's like they're equidistant from 45 degrees, even though it's not a distance, it's an angle, but whatever. Okay? Based on that information, 3 questions. Discuss in your small groups. We'll come back and discuss together. Go.
Thank you, sir.
And we're back. So, first, which projectile will have the longest flight time? The answer is 60-degree launch will have a longer flight time. Which one? What happens in the 60-degree launch? Where do you shoot it? Shoot it way up in the air, right? Second question, which projectile will have the greatest horizontal displacement? Kind of a trick question, but if we deal with landing at the same level, their horizontal displacement will be the same. Which projectile will have the greater speed before landing? Again, kind of a trick question, but they will have the same speed. Okay? Let's look. So, here's your projectile motion simulator that you were working on the other day. 30 degrees, 18 meters per second initial speed. Boom. There you go. Okay? Next, let's change this, see if I can actually change it to 60. be pretty tough. Pretty tough to do with the magic pen. No, I don't. Actually, I can get like a keyboard up on the board here, but it takes longer for it to come up and use it than just walking over there and pressing it. I mean, wouldn't it be convenient if there was actually a control station for the computer where the teacher actually stands?
Why don't they have
Yeah.
a keyboard on that little
You think
thing
it'll-
that you have?
Say again?
They should have a keyboard on that tab that you have.
I can get a keyboard, but like I said, like by the time like it comes up and I do like one
No,
thing
like
at a
one
time,
like on the board.
that would be nice.
I know.
So, yes,
Or
I
you could
agree.
just read your mind.
So there's 60 degrees, and boom, there it is. Okay. Now, if you look at this picture, right? Contrary to what I just wrote up on the board, let's grab this. They don't have the same horizontal displacement in this picture, but that's because do they land at the same level that they were launched from? They don't, right? If I was to draw a line starting here and coming all the way across, what do we see about where they intersect? At that same height that they started from. But, John, if we're looking at this picture, right, what do we see about the one that was launched at 60 degrees? It goes a lot what? It goes a lot higher, so how long is it going to be in the air? A lot longer, okay? This will be the case, the same horizontal displacement, but the difference in flight time, as long as you have two angles that add up to 90, like 30 and 60, 40 and 50, 20 and 70, that will be the case. None of them will ever get to as long of a horizontal displacement as 45, but we'll see a similar displacements. Okay? Good there? Questions? The last type of problem that we talked about, dealt with something starting up on the ledge. Here's my ground. And now we're launching this object like this, right? Go ahead, I'm
I
sorry.
actually do have a question. So if they don't add up to 90, they're gonna have different.
They will have different horizontal displacements then.
Okay.
But the thing about the two angles adding up to 90, the one thing that makes them that way is that like with 30 and 60, you use sine and cosine to find the initial velocities, but sine of 60 and cosine of 30 are the same number, and vice versa, so that's why we get, the flight time is different, but we'll end up in the same spot at the same speed in both cases. Okay. All right, good there? So, last type of problem we did looked like this, where now we take this object, we launch it off of a ledge, and then now it ends up down here somewhere, right? Or, more specifically, or more generally, it ends up not where we shot it from, okay? We still start off this problem like this and like this, and those still become our initial horizontal and vertical velocities. Sorry, I made them the wrong colors. Apologize. Now I had this is gonna be out there on the internet, I've got random people liking my YouTube channel because they see this video. They're like, "Wow, this video is great." I'm not even joking. last year, some guy with a username Vortex Lord liked my station. I was like, "Whoa, Vortex Lord!" So anyway, I don't want people to start commenting and be like, "Oh, he switches his colors right in the middle of the video." So,
Vortex Lord's gonna watch this video.
I'm pretty sure. That's why I changed it though. So now Vortex Lord, I'm sorry. Apologize. So, I also get like random emails now that like say, "Hey, I just watched your video and it's great. Do you want 10,000 guaranteed views?" I'm like, "No, not really. I don't." So, anyway, so problem starts the same. The only thing that's different now, right, is that now there's some displacement, right? Delta y is now not equal to 0. In this case, it would be what? What sign would displacement have in this case? Negative, right? But it wouldn't be any different if I started it down on the ground and shot it up. My delta y would be positive then. Good there? All right. Last for today? Don't look.
Oh, do you want me to
Go
read?
outside for a second.
Okay.
We're almost done anyway, so. Anybody else not take the quiz? Well, you didn't take the quiz, now go outside. Do the quiz. Yeah, you took the quiz. Okay, another call. Alright, so, this question, very similar to the question on the quiz, from Friday, where we have this object that's being launched like this, 60 degrees above the horizontal. And it's got a horizontal component and it's got a vertical component. There they are, okay? But, let's see if this works. There we go. Ooh. Oh. Oh, there it is. Alright, but this one, no, it's not exactly right, but this one also gets now thrown downward, but at the same angle that this object was thrown upward. What would we say about their horizontal components here? Are they any different? They're exactly the same. They've still got this horizontal. But now, the vertical is actually going to be the same, but in the downward direction. Does that make sense? By the time the top one gets all the way back over to here, or the same level that it got launched from, right? That's a pretty good guess as far as getting it back to that line, I have to admit. So. What has happened to its vertical velocity? It's switched. And now it has a vertical velocity that looks something like this. Is it any different from the one that got thrown down originally? No, it's not. So they would hit the ground with the same speed. Will they hit the ground at the same time? No, it's not, right? It's not this problem, right? It's not different velocities horizontally. They won't hit the ground at the same time, but they will have the same speed because by the time the projectile gets back to the level it was launched from, it looks exactly the same as the other one. Good there? Don't be fooled, please. This is not what the path would look like on the downward one. It would actually go something like this. Okay, it wouldn't go out farther than we threw it from, so don't make that mistake. It's just the way I was flipping things around. So, okay. Good there? Questions? All right. If you have questions, you can email me. Answers to all the example problems are posted online. Lots of class recordings, and I will post this today and these slides as well. Okay? Let me know if you have any questions.